One of the physical properties I want to mention about solids is specific heat. This is something we track for also liquids and gases, but we use it a lot for solids because we often use solids to heat other things. So your cast iron pan at home has a specific heat, and that specific heat is how much energy is absorbed before it increases in temperature itself. So specific heat is really then, we define it specifically as what is the change in the temperature of 1 gram of a substance by 1 degree Celsius. How much of that energy is needed to make that happen? And that changes based on the substance. So different substances require more or less energy to increase in temperature by 1 degree Celsius. And this is really getting at this idea of how heat flows. So everything will absorb heat or release heat, and which one it does depends strictly on what it is around. So if I have hot coffee in a cup, it will be hotter than my hand holding it. And so if the hand is cooler and the coffee is hotter, heat will always spontaneously flow from hot to cold until both are at the same temperature. And my hand would be hotter than ice, which would be cooler. And so heat would flow from my hand to the ice until they were both at the same temperature. And so if everything can release heat or absorb heat, we track how much of that heat's required to change the actual temperature of the substance with specific heat, which is basically saying it takes a compound, it'll be able to absorb a certain amount of heat before it actually changes temperature. And that'll be unique to each compound. So the specific heat equation that we use is, so you'll see specific heat written as SH or CS as well. And this is the variable. The variable has units of joules or calories, which are measures of energy, by grams, which is a measure of mass, and degrees Celsius, a measure of temperature. So it's the amount of energy to raise 1 gram, 1 degree Celsius. And so you can think of that equation like this, where specific heat is on one side, or it's more typically thought of, it's rearranged to say that the heat of something is really going to be the mass times the temperature change times specific heat. And so we can calculate this for a substance by measuring the change in temperature that something undergoes. If we know its mass, we'll know how much heat flowed into the substance if we also know the specific heat for it. And these are usually values that you can look up in a table. And they're often published. So let's take an example. As I read this problem, I want to know what the specific heat is for something that is 24.8 grams. It's a metal, and it can absorb 275 joules of energy as the temperature increases by about 4.3 degrees. So my mass is equal to 24.8 grams. The larger something's mass is, the more heat it can absorb. The energy, or the heat, let's put it like that. Heat and energy have the same units, because they're a measure of the same thing, 275 joules. And we have our change in temperature is always going to be equal to the final temperature minus the initial temperature. So that's 24.5 degrees Celsius minus 20.2 degrees Celsius. So if this is Q. So if I wanted to calculate the specific heat, would be equal to the heat that's measured divided by the mass times the change in temperature. So for us, this will equal 24.8 grams, or sorry, 275 joules divided by 24.8 grams for our mass. And our change in temperature is going to be 4.3 degrees Celsius. And we get a value that is 2.58. And the units here are going to be joules per gram degree Celsius. I could convert this if I wanted into calories. If I did, it would be 2.58 joules per gram degree Celsius times my conversion factor that'll put joules on the bottom so they cancel out, and calories on top. And 1 calorie equals 4.184 joules. So this will then be equal to 0.616 calories per gram degree Celsius for my units. See, my joules cancel here.